Ask any group of database professionals, say you have a combination of DBAs and architects, a project manager, application developers, database modelers, how to optimize the system, and you'll end up with a myriad of different ideas. And then each of those ideas ends up competing for limited resources. So to figure out how to best spend those resources so we get the most bang for our buck, let's begin by talking about what is a database system. And I use the word system here in the technical sense, meaning that a system consists of multiple components, and altering the behavior or performance of any one component will affect the performance of other components and the overall system performance. Within a database system, I see four broad components. The database component will consist of all the code inside the database, the schema, the queries, the data, the indexes, all of the objects within the database file. The server is that broad component that consists of the hardware, the operating system, the SQL Server installation, everything that involves the platform on which the database is executed. The third component is all of the daily and weekly maintenance jobs run by the DBA or by SQL agent that help keep the database defragmented, the index statistics up to date, and so forth. And the fourth component is the data access code and the way that that's written and the way that the front-end client, whether that's a layer or an application or an ETL or a report, interfaces with the database. All four of these components need to be functioning well to have a good database system. But when we think about the interaction of these components, the database itself is the one that's most complex, and the design of the database significantly influences the other three components. For example, the design and therefore the workload of the database determines the requirements for the platform and the work required by the maintenance jobs. And the simplicity or complexity of the database vastly determines how the data access code can interact with the database. I believe the design of the database is the single greatest factor in the overall performance of the entire system, and the ROI or return on investment of the database design far exceeds the ROI of any of the other three components. I sometimes visualize the performance of a database being similar to that of a bubbler, which is a childhood term of mine back in Wisconsin of what we would call water fountains. And I think a bubbler is a good metaphor for database performance. The idea being that on a hot summer day, if everyone comes to the bubbler and takes a quick sip, then no line forms. But as soon as someone walks up there and starts filling up their 32-ounce big gulp glass, now we have a line being formed. And the lesson of the bubbler for the database is that the way to reduce the overall aggregate workload of the database is to focus on each individual transaction and to make those transactions really tight and small. So if the database itself is the central component of the overall system, and it's the one that determines the performance and the requirements of the other components and the overall performance of the database system, then that's the way to find performance, is to analyze those transactions and figure out how do we make tight, fast transactions so every user just comes and takes just a sip from the database system.